Section 8.5 is about solving by completing the square. We're going to start off by first kind of exploring what it means to be a square, or what the square of a trinomial is. So first off, example 1, if we look at, we need to factor this trinomial. We have x squared plus 16x plus 64. Then we want to describe how 16, so this piece right here, and 64, this piece right here, from the original expression are related to the number in the factored expression. So first off, let's factor it using the AC method. Our A value, there's a hidden 1 out in front of here. Our C value is 64. So AC, we do 1 times 64 is 64. What are the factors of 64? We have 1 times 64, 2 times 32, 4 times 16, or 8 times 8. Now what two of these factors will add up to make positive 16? Well, we should be able to notice fairly easily. That would be 8 and 8. 8 plus 8 is 16. So we'll break it up into 4 terms. This 16 turns into 8 and 8. So x squared stays from before. This 16x turns into a plus 8x and plus 8x, and still the plus 64 at the end. Now, we're going to factor by grouping. We have our first group here and our second group right here. If we look at that first group, we can take x out of both of those. So it looks something like this, x on the outside times the binomial 8 or x plus 8. If we look at the second group, we can take 8 out of both of those, positive 8. 8 times what would make 8x? Well, that would be x. 8 times what would make positive 64? Well, that would be, so this is going to go, that would be 8. So now we have our first step in our factored form. We've factored both groups. Now we can put these together. Notice that we have x plus 8 and x plus 8 right here happening both times. So our first one would be x plus 8. In one case, it's being multiplied by x. In one case, it's being multiplied by positive 8. So our other factor is positive 8. Now notice we have this binomial in red, x plus 8, times this binomial in blue, which is also x plus 8. So we can call that x plus 8 squared. Remember, squaring something just means that number multiplied by itself. X plus 8 as a binomial multiplied by itself, which is what this is right here, means the same as x plus 8 to the power of 2. So, if this is our factored form, x plus 8 squared, we need to describe how 16 and 64 from the original expression are related to this number 8, positive 8. Well, 16 is that number, that positive 8, times 2. So the middle term is this piece times 2. And the last term, that 64, is this piece squared. So if you ever get a factor or a factored expression like this, x plus something squared, this piece times 2 is going to be our middle term, and this piece squared is our end term. Solve each equation by taking the square root of each side. So notice how if we look at this, after we factored it, we got it into x plus 8 squared. So we can take the square root of that now that it's a squared expression. So just like in our last one, the first thing we need to do here is factor it. Now, we don't need to factor 36, we just need to factor this expression, x squared minus 20x plus 100. Just like before, we use the AC method, a being 1 out here, c being 100. 1 times 100 is 100. So the factors are 1 and 100, 2 and 50, 4 and 25, 5 and 20, 10 and 10. Now, this is a positive 100, so either these can all be positive factors or they can all be negative. Since this middle term is negative, we want all of these to be negative. And the question is, which set of factors will add up to that middle term, that negative 20? Again, it should be fairly obvious at this point to see. It would be negative 10 and negative 10. So we break up that piece into x squared minus 10x minus 10x plus 100. Factor by grouping, just like we did before. our first group and our second group. Notice again this second group has a negative 10x out front. X squared minus 10x, what could we take out of both of those? It would be our x, and it would leave x minus 10. Now, if we want this piece, this second group, to say x minus 10, what would we have to take out of both pieces? Well, that would actually be minus 10, or a negative 10. Now, I could take positive 10 out of both pieces. If I did, that would leave me with a negative x plus 10. That wouldn't be the same as x minus 10. We want this piece in red to be the same as this piece in red. That's why we had to take out a negative 10. Now x minus 10 in red happens twice here and here. Now in this case it was multiplied by x right there. In this case it was multiplied by negative 10 right there. So when we factor this piece out, it's x minus 10 times x minus 10. Or we can simply call it x minus 10 squared. So we can say this whole thing, this whole expression, is x minus 10 squared, that was this left side, equals 36. We are asked to solve by taking the square root of each side. So at this point, we would want to take the square root of both sides here, here, and here. Remember, if we take the square root of something that was squared, these two essentially just go away. So we are left with x minus 10 equals, now the square root of 36, remember there's a positive and a negative, so it's plus or minus 6. Now we still need to get x alone. How do we get x alone on both sides? Well, we have to add 10 to both sides of the equation, so we get x equals positive 10, that 10 that we just added, positive 10 either plus 6 or positive 10 minus 6. If we did 10 plus 6, that would be 16. If we had 10 minus 6, that would be 4. So our two possible answers in this one would be x equals 16 or x equals 4. Example 3, find the value of c that makes each trinomial a perfect square. Then write the trinomial as a perfect square. Now remember, the term perfect square means a number that can be written as some other number squared. So for example, 25 is a perfect square. Why? Because we can write it as 5 squared. We can also write it as negative 5 squared. Either one works. But 25 as a number, we call that a perfect square because it can be written as something else squared. So how can we make this expression into something where we can have another factor, another expression, a binomial squared would make this expression here? Well, first off, to find that value of c, we take half of the middle coefficient and square it to find c. Because remember, going back to this first one, where did this 8 come from? Well, it comes from half of this 16. Where does this 64 come from? It comes from this 8 squared. So back to this one, we would take half of this middle number, square it, and that would be c. Well, what's half of negative 24? That would be negative 12. I'm going to write this off on the side. Now if I did negative 12 squared, so negative 12 times negative 12, that would be positive 144. So c equals 144. Now how would I write this as a binomial squared? How would I write it as a perfect square? Well, remember that minus 12? We just put it behind t, so t minus 12 squared. Now this piece, if we were to FOIL it out, would become this expression. Let's look at another example then. Again, take half of the middle coefficient and square it to find c. What's half of 28? Well, that would come out to 14. What happens if you take 14 and square it? Well, that would leave us with c equals 196. Now, take the variable plus or minus half the coefficient in the middle term, all in parentheses, and squared that. That's the perfect squared. So like this one, our variable was t, minus half of that coefficient, so minus 12, like this, all in the parentheses squared. So same thing on this one. We want to take h as our variable, plus 14, and then square it. Oops, I guess I didn't notice this is supposed to be a 28h. If you want to write that in, make sure you know this was our middle term. This should have had the h with it. So this would be our perfect square. So this is kind of our concept summary for this lesson. It's completing the square. There are 7 steps into completing the square. The first one is if you start off with an expression where your a is not 1. So remember your ax squared plus bx plus c, those are the kinds of expressions we're working with. If a does not equal 1, we divide each term by a. That way a would be 1. Now that you've got a equaling 1, you subtract the constant term, c, from both sides of the equation. So now one side of the equation should just be x squared plus bx. Then, kind of off on the side, you find half of b, and then you square it, just like what we did. That number that you get, that half of b squared, you're going to add that to both sides of the equation. You factored the quadratic side then, and it should come out to x plus b over 2 squared. Kind of just like how we did over here. This came out to t minus 12 squared when we factored this piece. Well, that's what should happen over here when we're solving by completing the square. Next, you solve by taking the square root of each side of the equation, which we've already done in previous lessons. So let's see this in action. Let's see a couple examples of how this looks. Example 4, we need to solve the equation by completing the square. Step 1, we're going to try to divide by a. Now in this case, a is 1. We've got 1w squared. So we don't really need to divide everything by a, because dividing by 1 just keeps everything the same. So we can just say that one's done. We already did that. Now we're going to subtract c from both sides. In this case, c is this positive 24. So we're going to subtract 24 from both sides of the equation. When we do that, we get an expression that looks something like this. W squared minus 14w equals negative 24. This one cancels out. 0 minus 24 is negative 24. Kind of off on the side now, we need to find half of our b value. Now remember, our b value is this negative 14. So half of our b value, 1/2 times negative 14, or if you like decimals, 0.5 times negative 14 is negative 7. Don't do anything with that number quite yet, or at least don't put it into our expression. We take that number, negative 7, and we square it. That's step 4. So negative 7 squared equals 49. That number, 49, that's what we're going to add to both sides of the equation, step 5. So we've got this side and this side. We're adding 49 to both of them. W squared minus 14w plus 49, this is one side, equals negative 24 plus 49. This is the other side. We can simplify that. Negative 24 plus 49 is 25. So here is our simplified equation at this point. Now we need to factor the left side. Step 6 is factor. If we did this correctly, this should factor out into a perfect square. So it would be w minus 7 squared. Notice how this minus 7 and this minus 7 from step 3, it's the same thing. And it's just our variable w minus 7 squared. That's what this whole left side becomes. Set all of that still equal to 25, this number on the end. Now we solve it by square rooting, like we've done in the past. So we'll take the square root of both sides, square root of this side, square root of this side. If you square root something that's squared, they cancel out. So it just leaves w minus 7. Square root of 25, remember, is positive and negative, so plus or minus 5. Now that we have w minus 7, we need to add 7 to both sides of our equation. When we do that, we'll get W all alone equals 7, that's 7 that we added, positive 7 plus or minus 5. Now in one case we could do 7 plus 5 and get 12. In the other case we could do 7 minus 5 and get 2. So we'd have two answers. One, W equals 12. The other one, W equals 2. So those are our two answers when we solve by completing the square. Let's try it again. Another example. This time we didn't have a 0 right here, and in the end we also won't get a perfect square number that our binomial equals. So let's try this out. I'm going to divide both sides by a. A is 1, so that part is already done for us. Step 2, subtract c from both sides of the equation. So what does that look like? We're subtracting 50 and subtracting 50. This minus 50 is going to cross out. 9 minus 50 is going to become negative 41. So we've got x squared plus 18n all alone equals negative 41. Off on the side, find half of b. Well, that would be half of 18, which is 9. Square that. 9 squared is 81. Add that to both sides of the equation. So add 81, add 81. Simplifying the right side here, negative 41 plus positive 81 becomes 40. This piece we can factor, so we do so and we get n plus 9, all of that squared, equals 40. Remember, this plus 9 or positive 9 came from right here. It's this 9 value. Now we solve by square root, as we've done before. Square root of this side equals the square root of this side. This one and this one cancel out. So we get n plus 9 equals the positive or negative square root of 40. Now at this point, don't solve that out as a decimal value. Keep it as the square root of 40 because we don't know exactly how big it is. If it came out to an exact number, like in our last one, we had the square root of 25 was exactly 5, then we can do exact, but this one doesn't come out exact, so leave it like this for now. To get n alone, we have to subtract 9 from both sides. Minus 9 and minus 9. So we get n equals minus 9 or negative 9 plus or minus the square root of 40. If you want, you can call this your answer. This is a nice simplified form. That is okay. If you prefer to get things as a little more exact, you can do this on your calculator then and get kind of a closer exact decimal answer. Negative 9 plus the square root of 40, and you'd get negative 2.67, about that amount. That's rounded. Or you could do negative 9 minus the square root of 40, and you'd get about negative 15.32. So if you prefer to put things in their decimal approximations, it would look like this. But if you want to leave things like this, both are acceptable answers. All right, let's do one last example where a is actually not 1. So in this case, our a value is 3, so we need to divide each term, this term, this term, this term, and this term. Divide each term by 3. We're dividing everything by a, so we're dividing it by 3. 3 divided by 3 is 1, so this is just 1x squared. Negative 9 divided by 3 is negative 3, or a minus 3x. Negative 3 divided by 3 is negative 1, or this minus 1. And 21 divided by 3 is 7. So now we've got it into a form where our a value is 1. From here, we subtract c from both sides. So we're subtracting a negative 1. Remember, if you subtract a negative, that's like saying positive, or adding 1 to both sides of this equation. When we do that, we get x squared minus 3x equals 8. Off on the side, calculate half of b, so we're looking for half of negative 9. Oops. Actually, in this case, we're looking for half of -3. We're not using this one anymore. We're using this one. So we're looking for half of -3. This should be negative. Oops. Undo. Just wanted this one to be negative. So that means this should be a negative value. -3/2 or -1.5. And when you square it, let's get this out of the way. So then when we square it, -1.5 squared is 2.25, or 2 1/4. That's what we're going to be adding to both sides, that 2.25. From here, we now simplify our equation, and we get x squared minus 3x plus 2.25, or 2 1/4, equals 10.25, or 10 1/4. Now, it might be kind of hard to see how to factor this as AC, but remember our trick. It's always our variable, and then we just add on this extra piece, this number, and then square it. So it would be, oops, not, and this should be an x. Oops. X minus 1.5 squared equals 10.25. I think from here on out I might have accidentally used the variable n. Just pretend it is an x. So x minus 1.5 squared equals 10.25. Now we just solve by square rooting. Square root of both sides. That's going to cancel out this squared piece. So we just have n minus 1.5 equals square root of 10.25. And again, remember, because this does not come out to an exact answer, just leave it as the square root of 10.25. I'm going to move that piece over. Now, how do we get n alone? We will simply add 1.5 to both sides of the equation. When we do that, we'll have n equals 1.5 plus or minus square root of 10.25. So you can leave it like that. Remember, that is an acceptable answer. Or if you like being a little more exact with your decimals, you can spell it out on the calculator. Do 1.2 or 1.5 minus the square root of 10.25, and you get -1.70. Or 1.5 plus the square root of 10.25, and you'd get 4.70. So again, they are both acceptable answers. Both of them show that there are two possible answers for this one. One is kind of more of an exact decimal answer. One of them leaves it in the radical form. But both are acceptable. And this is how you solve by completing the square.